Hello. Well, thank you for listening to me today. I'm going to present robots tests for unconventional environments. And this is just a presentation of me sharing the challenges that we face while building an unconventional application, and how tests actually helped us make the development faster and, as Josh said, make our lives better. My name is Carolina Pinzon. I come from Colombia. You can find me in GitHub or Twitter, LinkedIn as Caro Pinzon Silva. And I'm a front-end engineer at Dapper Labs, where we believe that the blockchain is for everyone. So because of that, we built games on top of the blockchain to prove its actual value. And the mission that we want to do is connecting blockchain to a broader audience. That's what we want to do, and we do it with games, because why not? And in Dapper Labs, we have this product called Dapper. What is it? It's a wallet that people can use to connect to the blockchain. The reason that we built this wallet is because we want to make it's really hard for you to get into blockchain. You have to download this extension, and sometimes there's a lot of things that people just don't get. So we want to make this friction. We want to decrease this friction for people to get into blockchain. So similar to any wallet application from a bank account, Dapper allows the user to do transactions in the blockchain. That's its main purpose. But what makes Dapper such an unconventional application? Well, there's this list of things. It's an Ethereum smart contract wallet built as a Chrome extension. It's a React application. It interacts with decentralized games. So at this point, I think you might have a lot of questions, what is a smart contract? What is Ethereum, maybe, if you don't know? How does Chrome extension work? What is a React application, maybe? And what is a decentralized games? And it's Carolina just saying a lot of random words here to confuse you. I promise you it's not. So let's go through each of them and explain them a little bit more. So Ethereum is a blockchain. And what is a smart contract? So in a centralized application, in a conventional environment, you have the code written in any language that you want, and you deploy this code to a server. And then the user can use the IP to make HTTP requests to interact with the code. Well, in a decentralized application, it's pretty similar. You have this code, which is called a smart contract, and you deploy it to the blockchain, which is just clusters of computers. Think about it like that. And then the user can use the address to interact with the smart contract, with the code that you deployed. OK, next point. What is a Chrome extension? This is an architecture of how a Chrome extension works. You have this thing that's called a pop-up. That is this window that appears when you click on the icon of the extension. The pop-up has a script running. Apart from this, you have the background script that is running all the time in your window instance. And the third component that you need to know about is this content script that gets injected into the application, so into any page. It gets injected, and it communicates with the background. And just like a side note, the content script has a lot of power, so be really careful on the extensions that you download, because it can do a lot of harmful things. React application, I'm not going to talk a lot about this, because hopefully you guys have a lot of context about this point. And it interacts with decentralized games. What are decentralized games? Are games that are built on top of the blockchain, and they use the blockchain as a database to save the information of the ownerships of tokens and assets. And this is what gives blockchain games its real value, the true ownerships of your assets. So some examples that we have in Dapper Labs, we have CryptoKitties, which is a game where you can collect and breed one-of-a-kind creatures or assets that we call kitties. And they have, each of these kitties has specific traits that make it special. And the other one that we have is Cheese Wizards, where you can buy a wizard, and they fight between each other to gain more power. And at the end of the tournament, the wizard that has the most power would be like it's the big cheese, we call it, and they win the prize. This is actually not related to the talk, but I think it's really cool, so go check it out. So yeah, those are examples of decentralized games. And how did we build this application? So we started the development like 1 year ago. And we had no, like everything that I just explained, this is me knowing now after building it. We had no idea what we had to do. We had some, we did have some experience with some blockchain games, but it was the first time building a wallet, so we just had like all these questions that you might wonder. Yes, and we started like around 1 year ago with just a creative React app, and then 7 months later, we did the public launch. And I wish I could say like, okay, we were like smart and we started tests from the beginning and everything was smooth. But it was not like this did not happen. It was painful at the beginning. The first months we lost a lot of time and we had a lot of time wasters. So a lot of unsuccessful QA sessions. So I don't know if you remember, but James said like, okay, raise your hand if in the 90s you were used to like having QA sessions, manual QA, blah, blah, blah. So for us, it was not in the 90s. It was in 2018. And the QA team was like us. So we did these QA sessions every week. We invited people from our team, people from product, from marketing, from design. And then we were like, okay, we want to QA the onboard flow, for example. And sometimes when we got into the QA session, people couldn't even open the extension. They were blocked and they couldn't log in. So it was a waste of their time. We had to reschedule the meeting. And then we had to fix as fast as we could this bug, schedule another meeting and try it again. Also, multiple fixes for the same bug. We kept breaking things that we fixed the last week. And a lot of manual testing from people from outside the team and also from us. So to test anything, we had to pull down the branch, build the extension, upload it to Chrome, and then try to test it. So it was not working. And I have some examples of the bug reports that we had at the beginning. So yeah, people were unable to even open the extension. Or this one is funny. We added end-to-end test, and it broke the production version, not the staging, not anything else, the production one. Also error during logging, so weird or vague error messages. And this one, the activity list is a feature that we have. So in November 22, someone reported that it was broken, and then we fixed it, and then some days later, it's broken again. So it was just not working. Yeah. So I can point a lot of challenges that we have, but I'm only going to share 3 that I think tests helped us to overcome them. The first one is that blockchain transactions are really slow, and they cost money. So like a comparison with a centralized application like Visa, they can process around 45,000 transactions per second. Blockchain can only process 10 to 15 transactions. And that's because they need all the nodes to help with the transaction process. And it also costs money. And every transaction that you want to do in the blockchain, you need to pay this gas, this network fee. The network fee changes according to how fast you want your transaction to be, the transaction that you're doing, or how many people are using the network at the time, so the network congestion. But let's say it's around, I think the average right now is around 25 cents per transaction. We do have there is a testing network. It's called Ringv for Ethereum, but this network is even slower than the mainnet. So it was challenging for us. And do you remember this diagram of how a smart contract works? Well, in Dapper, we deploy 1 smart contract per user. So that means it's similar to saying, OK, we are going to deploy 1 server per user. And this is the core functionality of our application. If this doesn't work, if the deployment or the wallet creation doesn't work, basically the product is useless. And like there's no point of people using it. And especially since it's one of the first things that the user interacts with, once we lose this user, it's just like one less person that will use Dapper. So we were seeing this screen a lot at the beginning, like us as developers. Every time we needed to test the wallet creation, we were like waiting like around 1 or 2 minutes. And then this is actually Nick created, one of the developers, this punk screen to make it like more fun. And we spent a lot of time playing it. But it was just like a waste of time. And not only that, because it was so like slow to test, we did not test it all the time. It was just when you change something from the wallet creation, we tested it. Otherwise, it would just assume that it will work. And that's when we got to the QA sessions. And things were like just not working. So the solution that we had is like getting this local blockchain to work. So it's basically getting this architecture, production architecture, which is Ethereum, and then run a local instance of it in our machine using Get, which is Ethereum implementation in Go, in case you're interested. And apart from that, we also needed to pull down the API, because the API is the one that sends the transactions to the blockchain. So it all has to be like in one machine. Yes, and with this, we could like replicate as close as possible our production environment for the test. We thought about, okay, let's forget about blockchain. We just mock the API request or make sure that we send the current information. But we went one step like farther, and we tried making it as close as possible. So we like made more robust tests that gave us confidence as developers. Okay, the second challenge that we had was that the user has different expectations when interacting with an extension. So in a conventional application or a web page, this is Cheese Wizards, if the user opens a modal and then they write an email in the modal, and they go to refresh the page or like close the tab and open it back again, they don't expect the modal to be there with the information that they wrote. They know that if they want to complete a flow, they have to like complete it without closing the extension, without turning off the computer. And this is a little bit different from an extension, because the extensions, the pop-up acts exactly as a tab, like as a window. So every time the user like minimizes it by either clicking the icon or clicking like outside the icon, they are like closing the tab. So we have to deal with this, because it's really easy for a user to close the window, in our case, in an extension. So do you remember this diagram that I showed you before? Because the window, the pop-up is really easy to get close. We have to move all our logic, all our API requests, all our like Redux store into the background script. And what does that mean? Let's say this is like our onboarding flow. It's 3 steps: the email and password, the phone, and then a 2FA. So it looks pretty straightforward. At the beginning, we're like, okay, we got this. Like, we're not going to have any bugs in this. We were really wrong, because the user we can't tell the user, hey, don't close the window when you're doing this onboarding flow. Like, please don't click anywhere else in the window until you finish this. It's just not possible. And we were having like a lot of issues in which, okay, the user went to the second step of adding the phone, and then they closed the window entirely, and then we didn't have the email from the first step. So the solution, it's also manual testing, how we were testing this. If you see here, when I click the refresh button in the, I'm going to click it in 1 second. But when you click the refresh button, it is the same as closing and opening the window again, because it restarts the background script. And this was us at the beginning, like trying to test like all these steps, that all these steps work. So it was like going into the extension, adding an email, then closing the pop-up, refreshing the extension, opening it back again, checking if the input that the user wrote is still there, and also like writing the password. We can't really save the password in Chrome storage because it's sensitive information. So like also it was not like, we didn't say like, okay, let's save everything. We had to save just some specific things. So the solution that we had, it was, okay, the user is going to, how the user can interact with this is like separate steps. Let's test it like this. We have this flow, but let's test each step separately. So for example, in this flow, after the first screen, what do we need? We need the email to be the one that the user inputted, and the token to be the one that we receive from the backend. The second step is for us to receive to save the phone, and to create the user at the end. So if you think about it, just like testing what each page is responsible of. So the first page is responsible of saving the email and getting the token. Second one of saving the phone, and the third one to do the actual API call. And with this, like, it was not only beneficial for us because we could like make sure that we didn't break the onboarding flow, which is so important, but it was also it also helped us to have self-documented tests, self-documented code. So the test like said, okay, this is what the steps that the user would do. This is what we need to get from each step, and this is what like the result of this flow. And it was especially useful. Like this flow is pretty straightforward, but we have like other more complicated flows, and we like test helps us with that. And the third challenge that I want to share with you is that the extensions communication is based on window messages, as I said before. So in a conventional web page, the web page has the control of almost everything. So for example, if they want to do an HTTP request, when the user clicks a button, they just like do the request, wait for the response, and then do something with the response. For example, here, if you want to show more kitties, it's like that. They do the request and get the response and then show the kitties. But then in our case, in Dapper, it was a little bit different. In our case, let's say the user wants to purchase this kitty. When they click this button, the centralized game sends a message to Dapper, and then we like do something with this information. And of course, like our entire application is surrounded by this. Like it's made for this core concept of it. And okay, we were really excited to write tests because we saw the value of it. And then we heard about this magic tool called Cypress, and we wanted like to test it. But when we tried it, we realized that we couldn't even have it running. And it's because Cypress does not support browser-specific protocols. This issue is still open, and I know that Cypress is a sponsor, so it's issue number 1965, just saying. And the reason behind it is that how it works, it's Cypress loads an iframe that connects with the URL that you want to visit and you want to interact with this. So like we couldn't load our like a core, just a core architecture. Our architecture didn't allow us to load, like to even use Cypress. So the solution that we had, it sounds funny, but it's just, okay, try to make it work. Try to overcome these challenges and see what happens. So the steps that we have to do in order to run our Cypress test is first you build the extension, just as like we would do it normally with our Webpack configuration. Then run the local server that points into this folder that we just built. And this is like an additional configuration that we needed, was mocking the Chrome API. So yeah, that means that in Cypress, we are not actually using the Chrome API, we just mock all of it. This is, of course, not the best solution. We even had some issues that we could not capture because of this. So one issue was that the encoding and decoding of the window messages did not work. And we couldn't detect it with our tests. So yes, this is not the best solution. But at least we could get our tests working. We could overcome this. It was not like, oh, Cypress doesn't work. Let's forget about tests. That was at the beginning a little bit what we thought, but not at the end. And we could get the test running. We could start doing some TDD, and we could actually develop before our API was ready. So that helped us improve the development process. And then, as a conclusion, what I want to share is that, well, these are just some challenges that we faced. There are not all of them. I could spend hours telling you guys what the challenges that we had, some things that we could just not solve. But the challenges that I shared are relevant here because tests actually helped us with them to find solutions. And this is, what I showed here is what worked. We tried many other approaches that did not work. If you want to know about it, come talk to me. I do believe that fails are as important or maybe even more important than success stories. So if you're interested and want to know funny stories, just let me know. And we still have a lot of things to improve. For example, the Cypress test, we're mocking a core functionality of our application. But still, we could make it work and overcome these challenges. And setting up tests, as maybe some of you might know, is not easy. And Dapper is unconventional in many ways. But I'm pretty sure every application has unconventional parts. It's not really easy to start doing tests. You will find challenges, but don't get discouraged by them. Take the time to solve the challenges and to create robust tests because it will actually benefit you as a developer. And even if the deadline is close and you have no idea what you're doing, which was us around 1 year ago, take the time and try to overcome these challenges. And I don't know, some people ask, okay, what tests do we want to add? Where can we start? Because it's also, you can add as many tests as you want. Well, my advice will be focus on the problems that you have as a developer. So things that break often, things that you see yourself doing a lot of manual tests with, repetitive tasks, or just critical flows that if they break at 3 a.m., you will need to get up and fix it. Focus on these kind of challenges and try creating tests that will help you overcome these challenges. So don't think of tests as good for the product. Think it more as good for you as a developer. Because tests that make your life easier as a developer will make the product better because it will just help you save a lot of time and it will be beneficial for it. Take the time to write tests. Take the time to make your test as close as your production environment as possible. Otherwise, they are just useless. You'll have green checks, but they are not really helping you. And write tests even if you're dealing with an unconventional environment. And thank you so much for your time.